Hey everyone, my name is Keely Thomas, and today we're going to be talking about nuclear fusion. I imagine that when I say the word nuclear, most people will think of nuclear power plants, weapons, radiation, and the like, but these things actually involve nuclear fission, which is the opposite of fusion, so we're not really going to be talking about them. On the other hand, nuclear fusion happens when two atoms, like these lovely hydrogen isotopes we have here, collide with enough energy to fuse together their nuclei, creating a new element, maybe sending off some spare neutrons, and releasing energy. Lighter elements, such as hydrogen and helium, tend to favor fusion over fission because they'll actually release energy when they fuse, and in the universe things like to release energy. Heavier elements, like certain isotopes of iron and nickel, favor fission on the other hand because they don't release energy when they fuse. Fusion can occur when elements are superheated to temperatures of tens of millions of degrees Celsius and are densely packed together. Normally, atoms will repulse each other because of the similar charges of their nucleus, but under these conditions, the speed of the particles allows them to overcome these forces, and they can collide into each other and fuse. All stars, and our very own sun, are the product of nuclear fusion. Stars fuse hydrogen into helium, and if they're large enough, will fuse helium into other elements. They undergo fusion until they run out of fuel, and they can no longer counteract the force of their own gravity, and then collapse into red giants. Those larger stars I mentioned can fuse heavier elements until they reach iron, which leads to them exploding into a supernova, where the fusion of even heavier elements can take place, like gold, silver, and xenon. All of the elements here on Earth, from inorganic to organic materials, plants and animals and people, all of these things came from stars at the end of their lifespan. Really gives a whole new meaning to thanking your lucky stars, right? At this point, you may be thinking, okay, that's cool and all, but why should I care about it if I'm not a physicist? Unless you are a physicist, in which case, rock on. But the answer is that nuclear fusion could potentially be harnessed and used as a source of energy production here on Earth. A whole lot of energy at that, way more than fossil fuels can provide. Plus, it would be green energy! You know how we have the greenhouse effect and acid rain from fossil fuels? You won't get that from fusion. But that's not to say that's perfect. It'll probably still produce nuclear waste, much like fission reactors, either from the components of the reactors themselves after being bombarded with neutrons, or through the production of hydrogen's radioactive isotope tritium. Physicists haven't been able to recreate fusion on a large scale in labs yet, partially because of the extremely high temperature demands. The field still needs improvement in technology in order to foster the conditions for self-sustaining nuclear fusion, and though they're making progress, it'll probably still be a while before anything viable is created. Even so, this really is a fascinating field with a really bright future ahead of it. So, that's my rundown on nuclear fusion. Thanks for watching!